Okay.
And let's begin. We are ready to start the session. So a very good morning, Professor Harmon and Christine, and a very good evening to all the students and faculty members educators who have joined us here for this session today. I'm Devesh Lati, and I'm the program manager here at the Next Genius Foundation. The Next Genius is a registered charitable trust in India, and we help students with scholarships for their undergraduate education in the US. Today's session is presented by Professor Harmon, who is a faculty member at Ohio Wesleyan University, and a Next Genius is a partner. Ohio Wesleyan University is a partner with the Next Genius Foundation. So if you're looking at applying to OWU, please check out our program on our website and apply for scholarships. With that said, today we have with us two very special guests. We have Professor Robert Harmon and Ms. Christine Crosby. Dr. Harmon is a professor in the Department of Physics and Astronomy at Ohio Wesleyan University, also called OWU. Dr. Harmon earned a BS in astronomy at Case Western Reserve University, and then went on to earn a MS and PhD in physics at University of Chicago, where he won the Gregory Wenzel Prize for the best first-year graduate teaching assistant. Before coming to OWU in 1999, Dr. Harmon taught at Washington College and Randolph-Macon College, and was a visiting researcher at the Howard-Smithsonian Center of Astrophysics. So it's a pleasure to have you here today, sir. Again, it's a pleasure to have you, Christine, as well. Christine is the Director of International Admissions at Ohio Wesleyan University, and all of you who are applying to OWU, you're going to work in more close coordination with Ms. Christine Crosby in the coming few weeks, and of course in the coming few months. So with that said, I don't want to take any more time, and I'm sure the students are waiting to listen to you, Professor Harmon. Passing on the presentation to you. It's a pleasure to have you here today.
Okay, very good. Thank you very much. And I'm very happy that you said, oh, woo. That's great. It certainly sounded funny the first time I heard it, but I'm used to it now. So, and we like to go, oh, woo, you know, that sort of thing. So, all right, let me get my slideshow started so that then I can share the screen. Let's see, let me stop it because now my Zoom window went away. So let me say share. And then now let me start it. I hope it cooperates with me here. Okay, it's not cooperating with me. So I hate it when this, oh, okay, now it's liking me better. That makes me happy. Okay, and so see, still not liking me well enough yet because I want it, yeah. Because it's not showing it to me as the full screen. So
okay, I think it started sharing now. Yeah.
Yeah. Now, are you seeing just my slides, or are you seeing also, you know, like my notes?
We're seeing actually the full thing. You know, I can see the slides down there. So maybe if you use the slideshow, I think. Yeah.
Yeah, and I'm doing that, but then I tested this yesterday, and then now, of course, when I'm trying to do it here, it's fighting me. So. Okay, so let me see if I can get this to go again. All right, so I'm going to pull up Zoom here. I'm going to say share. And now I think it's going to be happy. Okay, so.
Yes, perfect.
Okay, so, right, now you're seeing what you should be, right? Just my slide.
Yes.
Okay, wonderful. Okay, so thank you all for being here. I'm going to talk about opportunities for physics and astrophysics majors. So I would like to start by saying something in general about physics and astrophysics majors, wherever you go. There's a difference between physics and astrophysics and most other majors, even in the sciences, in that there's kind of a core canon, if you will, of knowledge and abilities that all physics and astrophysics majors are supposed to have acquired by the time they graduate. And so to give you an example of what I mean, Here from the OWU catalog are our biology major requirements, and it'll be similar at other schools too. So this is just an example. Core courses are Biology 120, Biology 122, Chem 110, Chemistry 110, Chemistry 111, and either Zoology 261 or Biology 271. Beyond this core, the requirements are A, 5 additional upper level biology courses under the 400 level, blah, blah, blah. B, 3 additional science, math, or computer science courses. So notice that probably no 2 biology majors graduating from Ohio Wesleyan or other schools took the same sort of courses took all the same courses in their majors. Now let's look at the physics major requirements. So we've got general physics 1 and 2, contemporary physics, mechanics, thermal and statistical physics, advanced physics lab, electromagnetic theory, electronics, quantum mechanics, physics seminar, research, calculus 1 and 2, multivariable calculus, differential equations, introduction to computer science and programming. Notice nowhere did it say pick one of the following, pick 3 of the following, anything like that. And again, this is at Ohio Wesleyan, but it's going to be true pretty much no matter where you are looking to go to school. The physics major or the astrophysics major is kind of more set in stone as the courses that you take. And so what that comes down to is that my advice to you would be that you need to start right away in the major if you think you want to major in physics or in astrophysics. So here at Ohio Wesleyan, the way it works is when you're a freshman, you take the calculus-based intro physics courses along with calculus if you don't have enough calculus in your background, which is fine. If you already do, you might skip some calculus courses. Then you take contemporary physics in the sophomore year. Then in the junior and senior years, you take the upper level set of courses. If you're an astrophysics major, you also take a year-long astrophysics sequence during your junior or your senior year. What I tell students is that if you think you might want to major in physics or astrophysics, you have to choose your courses as though you're definitely going to major in physics or astrophysics until you possibly, I hope not, decide otherwise. So you can't sort of explore different majors and maybe land on physics when you're done. You got to start right away as far as that is concerned. So that's a general piece of advice. So I'm also talking about astrophysics along with physics. Many schools have a department that they call the Department of Astronomy and Astrophysics. When I was in graduate school at the University of Chicago, they have a Department of Astronomy and Astrophysics there. One thing I'm often asked by folks is, what's the difference between astronomy and astrophysics? And the answer I give is the one that I am stealing from Charles Bruce Stevenson, who was one of my astronomy professors at Case Western Reserve, where I was an astronomy major, which is that astrophysics sounds better at a cocktail party. What it comes down to is there isn't really a difference between them. They're not really 2 different fields. Sometimes astronomy is used to kind of refer to the more observational aspects of the field, and astrophysics to the more mathematical theoretical aspects of it. But that's really an artificial distinction. So astronomy and astrophysics are really the same thing. So what do astrophysicists do? Astrophysicists are really applied physicists. Astrophysicists apply physics and calculus to the study of objects in space. I always feel like I should say it with an echo when I'm talking about space, 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 space. So in this sense, it's really applied physics. So for example, equations that describe the appropriate physics are used to make computer models of conditions inside stars. We can't build them in the laboratory. It's an observational and computational science. So to understand how stars work, you need to be multidisciplinary within physics. You have to have some understanding of nuclear physics to study how energy is generated via nuclear fusion in the star's core. You need to understand radiative transfer to understand how that energy is generated that's generated in the core is transported out to the surface. You also need to have some understanding of fluid dynamics to understand convection and the balance between the inward pull of gravity and the outward push of pressure inside the star. Sometimes I find that prospective students who want to major in astronomy, astrophysics, have a misunderstanding. They think that astronomy is all about looking through telescopes. Maybe they don't understand that It's applied physics. One of the things I've been asked to talk about is what kind of student can thrive and succeed in physics and astrophysics majors. And I don't think I need to tell anybody that a physics student should be somebody who thinks well analytically, quantitatively, and likes math, is good at math. The same kind of student who succeeds in physics is the kind of student who will succeed in astronomy, because astronomy is applied physics and calculus. You need to understand those things. So if you're thinking about being an astronomer, then you should be a person who's excited about the idea of using physics and calculus in your professional life. So now let me talk about research opportunities that you might have as an undergraduate student. These days, graduate schools and private sector companies are looking for you to have research experience on your resume. It's really advantageous when you're applying. And that means that it's important for you to find out what kind of opportunities will be available at whatever school that you choose. So here's some possible ways that you can get involved in scientific research as an undergraduate. One is via something like a senior research project. So many schools, it's a graduation requirement for physics and astrophysics majors that in the senior year, you do either a one semester or year-long research project under the mentorship of one of the faculty members in the department. That's especially common at small schools, at liberal arts colleges, where there are only undergraduates, and so faculty can concentrate on the development of their undergraduate students. Another possibility is many schools offer paid summer research internships to their own students during the summer. Those typically are 10 weeks long. And again, you're working under a faculty member. Nice thing about them is, like I mentioned, you're paid to do the research. And again, many schools offer them, but not every school does. So it's something that's worth asking about at the schools that you're considering. Then there's also paid summer research internships at other schools besides the one that you're at. The U.S. National Science Foundation funds what are called research experiences for undergraduates programs, but unfortunately only U.S. citizens are eligible for those. But on the other hand, there are a lot of schools that have other sources of funding, and they will hire international students to take part in these programs. And I highly encourage you to try to get one while you're an undergraduate, because especially if you're looking to become a PhD or get a master's degree in the future, schools having graduate programs will often use these programs in order to recruit talented future graduate students. And again, even if your goal is to work in the private sector, it's good to have research experience. I will say, what you do research in isn't as important as simply that you do a research project. It's if you think, I want to be, say, a cosmologist someday, it's not particularly important that you do a cosmology project. Great if you can get one, but really what's more important than anything else is that you have the research experience. I like to give some real world examples of the things that I'm talking about, like people that I know who have done these things. So I'm going to use one of our recent graduates from Ohio Wesleyan, Derek Shank, who from the class of 2018, he majored in astrophysics and mathematics. He did a summer research project here at Ohio Wesleyan with me. We have what we call the Summer Science Research Program, 10 weeks paid summer internship. And then the summer after that, he got an RU project at the University of Notre Dame in their physics department. And they got to know him and he got to know them. And so when he applied to graduate school, they accepted him. And now he's in the PhD program in the Department of Physics doing astrophysics research. So that really paid off for him. Again, I highly recommend you try to get one of those opportunities while you're an undergraduate, of a summer internship like that. Now, given my audience today, I simply can't resist telling you about some of our great students from India that we have in the department now who've taken advantage of opportunities like this. So this is Sakshi Gupta, who is going to graduate next year, class of 22. She's from Navi Mumbai, and she did just this past summer a summer research project with me, star spots on LO Pegasi. Star spots are my research specialty. Because of COVID-19, she did it remotely from her home. So that was interesting. I am very familiar with the 9.5 hour time difference between Eastern time in the US and India, because we had to deal with it on a daily basis. So it was a very different feeling to do where I would be getting data all night long at Perkins Observatory. And then meanwhile, Sakshi and another student I was working with remotely in Japan were with me virtually gathering data during what was broad daylight for them. So that was a unique experience. And then we also have Akul Rishi, who is going to graduate this coming May. And the summer before last, he did a similar research project with me. He presented his research at the American Astronomical Society meeting in Honolulu last January. That's an advantage of doing research too, is that you can present at scientific meetings and get to know other students like you who are doing research, get to know faculty members who will come and see your presentation. And then you can talk about their graduate programs with them and so on and so forth. It's a great experience to have. Akul's now doing a senior research project with me where we're going to study gravitational lensing by rotating black holes. Okay, let's move on to talk about career opportunities for physics and astrophysics majors. So if you're thinking about physics or astrophysics, there's a good chance that maybe what you want to be someday is a professor. You want to be a professional researcher, go the academic route, where you get to decide what you want to research on, train students, train the next generation, and so forth. What we kind of call, what people kind of think of as the traditional career path for physics and astrophysics majors. It's often considered to be becoming a faculty member at a doctoral or research institution, a big school that has a graduate program. In order to do that, you're going to need a PhD, so going to graduate school is a must for that. One thing that I tell prospective students a lot, because I find that while some students and their parents know this, others do not, is that you don't pay to go to grad school in the sciences. I can't tell you how many parents I've seen breathe this big sigh of relief when they realize that while they need to help their child pay for their undergraduate education, they're not going to be stuck with also supporting them through 4, 5, 6 years of graduate school, because what happens is in the first of all, the graduate school will waive your tuition. You don't pay anything to go there. And second of all, in the first year, you're typically paid to be a teaching assistant. And then after that, you're paid to be a research assistant, typically out of a grant that the faculty member who is supervising your dissertation research will have money that they can use to pay you a salary. Now, you're not going to get rich on this, but for a single person, a single young person, it's definitely enough to live on. So that's some good news if you weren't aware of it already. It's a long road to get to the point of being a faculty member at a research institution. A PhD is not enough. You have to do several what we call postdocs, postdoctoral research experiences afterwards to gain independent research experience and establish a publication track record before schools will consider you for hiring, because they emphasize research and publication in their faculty members. And so you need to have established that you're capable of producing high quality research independently. Typical postdoc is 2 years, some of them are 3 years, and you need to do at least 2 or 3 of them in order to start being competitive to get a faculty job somewhere. Again, with some real world examples, this is Rachel Rotenbacher from the class of 2008 here at OWU. Rachel and I still work together. We still collaborate because she did star spot research with me and decided she liked it enough to keep doing it. She went to the University of Michigan and got her PhD back in 2015. Then she did a postdoc at Stockholm University, and today she's in her second postdoc at Yale. And so she's on the track where she's hoping to reach the point where she can become a faculty member doing research at a degree, at a PhD granting institution. Another real world example is Tony Wong from the class of 2010. He majored in mathematics and astrophysics, and then he went to graduate school in applied math at the University of Colorado at Boulder. And today he recently started as an assistant professor at the Rochester Institute of Technology in the School of Mathematical Sciences. So he's a math professor, but he's studying climate change. And climate change is applied physics. So his physics background was crucial to getting him where he is today, even though, strictly speaking, he's a math professor. He uses the tools of physics, the physics knowledge that he learned by being an astrophysics major in order to study climate change. Now, another route that one might take for a career path with a physics and astrophysics major is to become a faculty member at a liberal arts institution. We have those here in the United States. That also requires a PhD. Postdoc experience is advantageous, but not always required to get a job at a small liberal arts college. A difference is that there's much more emphasis on teaching at the small schools. So if your passion is teaching, and I discovered when I was in graduate school how much I love teaching, if you have a passion for teaching, then this could be a good route for you. It was a better route for me than being a researcher at a large institution, because research is important to me, but so is teaching. And so I wanted a situation where I would do a lot of teaching. At a big school, you might teach one course per semester or one course per year. At a small school, you teach multiple courses every semester. That's just the way I want it. It's expected and rewarded at a small school. What's also expected is that you will involve undergraduates in your research program, because at small schools without graduate programs, it's all about the undergraduates. And so you need to be able to have a program of research that can get them involved. In fact, if I can put in a pitch for small schools here, if you are at a small school without graduate students, then by definition, you're the kind of student that that school is about. The large schools with graduate programs, the faculty there tend to be most interested in educating their graduate students, because it's the graduate students who help them carry out their research and publish papers and so forth. And that's how they're evaluated. At small schools, where teaching is more important and we really value mentoring undergraduates, you are by definition the kind of student that faculty concentrate on here. We're all about you. So if you go to a small school as an undergraduate, and then if you're interested in grad school, you go to a large PhD granting institution where you're a graduate student, you'll again be the kind of student that the school's all about. So you get the best of both worlds. If you go to a small school, you're the kind of student at that time that the school is all about. Then you go to a graduate school, and again, you're the kind of student that that school is all about. So win-win in that situation. Just for fun, here's a real world example of somebody who went the route of becoming a professor at a liberal arts school involving undergraduate students in his research program. Namely, there I am in the middle on the observing deck at Perkins Observatory, where I have a computer-controlled telescope that I was involving those two fine undergraduate students in my research with. Okay. Now, I really want to emphasize that most PhD physicists and astrophysicists do not become professors. If your dream is to be a professor someday, go and try to realize your dream, but I urge you not to define your success in terms of whether or not you end up being a professor someday. Because many more PhDs are produced every year in physics and astrophysics than new faculty job openings become available. In the US, it's about 1,800 PhDs produced every year, and about 350 faculty jobs on average become available every year. So there aren't enough faculty jobs to go around. But I need to emphasize that a career in the private sector can be just as fulfilling intellectually. You can have a really fulfilling, intellectually stimulating career in the private sector. And beyond that, it usually pays better as well, which is nothing to sneeze at. So to show you what I mean by that, here is a graphic from the American Institute of Physics from a couple of years ago. Starting salaries for physics PhDs, excuse me, in the classes of 2013 and 2014 combined, for potentially permanent positions hired into jobs which are intended to become permanent. So notice at the top there, for the private sector range, we're talking starting salaries from about $80,000 to almost $110,000 per year. At university and four-year colleges, the range was more like $50,000 to almost $70,000 per year. So you're making a lot more money if you go into the private sector. So nothing wrong with that, right? So that is something to have as a consideration. Again, as a real world example, one of our students would be Taimur Islam. He majored in physics, graduated back in 2013. He and I are still in regular contact. And he got his PhD at Duke University a couple years ago. And we were talking about, he was thinking, you know, does he want to go the academic route? Does he want to be a professor? He didn't want to be a teacher at a small school. He wanted to go, if he was going to be a professor, he wanted to be one at a large research PhD granting institution. But he also could see himself as being happy in the private sector. And so we talked about it, you know, and we talked about how if you want to be a professor, you're going to have to be a postdoc multiple times. And there's going to be no guarantee that at the end of that, you're going to get a faculty job just because of the numbers. And if you think you can be happy working in private industry, perfectly happy, then that's probably a better option for you. And he agreed with that. And so now he works at Apple studying computer vision and self-driving cars, and he loves it. It was definitely the right choice for him. And so that was, you know, he's a resounding success. Sometimes there are professors who think that excuse me, the definition of success is becoming just like them, becoming a professor. Don't ever let anybody tell you that. You can be successful. Success means finding something that you find personally fulfilling, and Taimur definitely did that. But it's also important to say that not everybody is going to earn a PhD. Not everybody should go on to earn a PhD. In fact, the American Institute of Physics Statistical Research Center estimates that only about 1 in 7 folks who receive a bachelor's degree in physics are going to end up choosing to finish a PhD in physics. Only about 14% of all physics degree holders actually become physics PhDs and become, you know, quote unquote, traditional physicists. So what can you do if you don't have a PhD? What kind of opportunities are there for folks who have a bachelor's degree or possibly a master's degree? Well, one traditional route that people take is maybe your dream is to teach the next generation of young people. Maybe you want to teach physics in high school or be a middle school science teacher. In that case, a physics or an astrophysics bachelor's degree will prepare you well for that. But there are also jobs for you in the private sector. Physics bachelors working in private industry have excellent earning potential, and they tend to work in the same kinds of jobs involving computer programming or engineering as degree holders in those fields do, because you're receiving technical training. You are learning what we like to say are transferable skills as a physics or astrophysics major that makes you a candidate for any sort of technical employment like that. So let me show you another graphic from the American Institute of Physics that shows salary ranges for various bachelor's degree holders. This is between the 25th and 75th percentiles for each one. And notice physics does really quite well. It's pretty high up on the list. So a physics degree really can pay for itself. College is expensive, but you earn skills as a physics or astrophysics major that make you very marketable and give you a good earning potential. And again, that is nothing to sneeze at. One of our students who's a real world example is Guillermo Gutierrez, who graduated in 2018. He majored in astrophysics and in politics and government, and did some internships, including a science policy internship at the American Physical Society. He's not interested in going on to earn a PhD. He today is a data analyst at JDSat Operations and Big Data Sciences. And he recently started, he does want to earn a master's degree in operations research at George Mason University in order to increase his earnings potential. So he's interested in big data. He did a senior project where he was doing a big data project involving politics, essentially, because of his interest in politics and government. And so as a result of that, he parlayed that interest into what is turning out to be a very fulfilling career for him. One more thing I will say is that there's more to being a physicist than acquiring, and an astrophysicist than acquiring technical skills. Everybody needs to be able to communicate. So when you're taking quote unquote distribution courses or core courses, humanities courses, don't look at those as hoops you have to jump through. Look at those as part of your professional training. Look at learning how to write well and to speak well as crucial tools that you're going to need on the job and in the world, because you can have the greatest ideas in the world, but if you're not good at explaining them to other people, then they're not as likely to be implemented. All right, with that, I am going to stop and invite any questions.